In this video, we're going to have our first lesson on figuring out the volumes of revolution by Washer method. But in this case, we're going to be looking at just cases where we're revolving around the x-axis and the y-axis. And to start this off, we're going to look at an applet that I found on the internet. And here it is. We've got a region, and we're going to be revolving it around the x-axis in this case. And I can take that sample rectangle and revolve it all the way around, and we can see our washer, which is essentially a skinny cylinder with a hole cut out of the middle. And I can have all these different samples. So I'm going to show you the samples, and you can see as we move along that center hole is larger, and we want to add up all of those. So I'm going to reset this, and then we're going to grab, well, we can revolve the whole thing. So this is our final thing we want to end up on. But to get there first, we're going to show a number of washers. So here's 4 washers, and we're going to revolve it around. So there's one. See, I want to revolve all of them. There's the rest of them. And we can see right now this is rather chunky, not quite the smooth figure we want, but as we increase the number of washers, then we can see it gets smoother. And this actually allows us to take a look around at what it looks like from different angles. All right, and then we can make it transparent, and we can increase even more washers. So we've got hopefully a pretty good feel for what we're trying to do here. All right, so let's go and do the calculus of this. So let's first make sure we understand our formulas that are involved with a washer. So in this case, we have a cylinder. Our outside cylinder has a big radius r, and our inside cylinder has a small radius r. And the height, I'm going to call delta H, because our goal is to make that height approach 0, because we want lots of skinny washers. So if we want to find the volume of one washer, we're going to take the big cylinder, pi big R squared, times our height, which I'm going to call delta H, and we're going to subtract our little inside cylinder, this little blue one here, pi little r squared delta H. Now we can factor out, both of them have pi and delta H that's the same. When we factor it out, we get r squared minus r squared, like that. Big R squared minus little r squared. And I'm going to just rearrange the order of this, because we're going to be converting to an integral soon, and I really want that delta H on the end there. So this is the volume of one washer, but if I want to have the sum of all my washers as delta H approaches 0, now I use an integral. I've got pi, the integral, r squared minus r squared, and as delta H approaches 0, we call it dH. That is the formula for washer method. All right, so let's try it out right here. I'll write the formula again. I've got pi integral big R squared minus little r squared dH. Okay, so this is the picture we were just looking at the applet, and we're going to label the parts on here. I need my big R. My big R is going to be the distance from the center all the way up to this top function, and we should notice that that equals root x. That's going to be our big R. And then inside here we've got the distance for little r, and little r goes from the x-axis up to here, and that's up to this curve here, which is this function. That equals little r. My thickness is a distance across like this, so that's going to be delta x. And my washers start all the way out here at 0 and end at 1. So here's our integral, pi, the integral from 0 to 1. We said big R was this top function up here. That's what our big radius goes up to. So square root x squared. Little r goes up to our bottom function. So that's x squared squared. And then our height is measured as an x. So in this case, we have dx. This looks like a nice simple one to do by hand, so I'm just going to finish this out. Square root of x squared is just x. X squared squared is x to the 4th. dx, do my antiderivatives nice and quick. 1/2 x squared minus 1/5 x to the 5th. oops, not a 4, a 5. Try that again. From 0 to 1. When I plug in 1, I get 1/2 minus 1/5. I plug in 0, minus 0, plus 0. Clean up my fraction there. I've got pi. Common denominator is 10. On top, this would be a 5 minus 2. And my final answer is 3/10 pi. All right, let's now look at this in general. So we've got some rules. And so this is really what we were just looking at. This first one, we're revolving around the x-axis right there. And when we revolve around the x-axis, we're going to get, and let me just draw in our washer here. We're going to get a washer that, see, here's my big radius. That looks about right there. I'll move that shifted and we'll get a little color in there. So let's do this and this. And then I have to take out the center part. And so the center function, that's going to take about like so. And we'll just add some color on that one. So go white and white. There we go. And there's one washer. And we can see that its thickness is going to be delta x, because we're going across like this for x. Our big radius goes up to this top function. That means f of x is big R. And our small radius goes up to the bottom function. So that means g of x is little r. And we can see our washers are going to be going all the way starting at a and ending at b. So our general formula is pi, the integral from a to b. Our big R is f. Our little r is g. And then we've got dx. Okay, let's go over to this next one. Here, the only difference is we are going around the y-axis. And when we go around the y-axis and we draw in our washers, so let me get those ovals again. So if I take this oval and draw it all the way, that looks about right. And we'll switch the color on that. So red and red. Okay, and then we're going to draw another oval so that we take out the center part like this. And we'll make that one white. There we go. Now we can see that they're going to be stacked up and down from C to D. We can see that the width is delta y, our thickness. C and D are y values. My functions are written in terms of y, and my big radius goes all the way out to this one, which means, oops, this one is that one here. It goes out to here. That is big R, and then my little r goes out to here. So this is big R, this is little r, which means this function right here matches up with f of y. That equals little r. And so we can write this integral pi. My washers get stacked from C up to D. My big radius goes out to this one, which is g of y squared. Actually, I'm not going to write the y. So g of y squared minus f squared. Actually, it might be worth noting that the equation is in terms of y, so I'm going to just include that g of y. So g of y squared minus f of y squared, and that whole thing times dy. All right, let's try two more problems. So in this problem, here's our region is bound by x cubed right here. X equals 0, which is the vertical piece, and y equals 8. And we're asked to write the integral for the solid if it's rotated around the x-axis. Now, I'm not going to draw those ovals every single time. I'm going to go to where I just draw the radius. So the radius, and remember I said I was going around the x-axis. So when I draw the radius, I start from where I'm revolving. I'm revolving around the x-axis, and I draw it up to the top function. That is my big R. And then I draw my little r up to the lower function. That's little r. If I look at big R, I can see it always goes up to 8. So big R equals 8. Little r goes up to this curve right here, which is x cubed. So little r is x cubed. And I can see that these washers, and I drew the radius for them so you can envision, and I'll just draw one in here real quick so we know what I'm trying to talk about. What I'm envisioning is this, like that right here. Here's an idea of what my washer looks like. So this washer, and it has a hole in the middle, right, like something like that. Those washers are getting stacked from left to right. So I'm going to start at 0, and my last washer is going to occur out here at 2 because that's where the region ends. So here we go. We're going to write our integral. The integral from 0 to 2, we need a pi out front. My big radius is 8. My little radius is x cubed. I'm going to square that as well. And dx. This time we're not going to evaluate it. I want to really focus on being able to write that integral. All right, so we've got one more here, and this time we are revolving around the x-axis. So if I'm going around the x-axis and I draw my radius, I am starting at, I'm sorry, y-axis. I think I said x. If I'm going around the y-axis and I start drawing my radius at the y-axis, so I draw it all the way to this far function, that's big R. And here I draw this one all the way to this one, that's little r. All right, so big R is, oh, it's this linear equation, and here's that linear equation. The only problem is notice that my width is delta y. And if my width is delta y, that means my limits are y values, and my equations have to be in terms of y. Equations in terms of y. So I'm going to have to solve this linear equation for y. So let's start by doing that. So y equals negative 1/2 x plus 3. I'll subtract 3. Y minus 3 equals negative 1/2 x. Multiply by negative 2. Negative 2 plus 6 equals x. So that is big R, negative 2y plus 6. Little r goes to this curve, natural log x, and that's pretty easy to solve for x. X simply is e to the y. So little r equals e to the y. And I think I'm just about ready to write this integral. So here we go. Pi, the integral, let's see, I'm going to start at 0. There's 0. Oh, wait. What is this y value right up here? This isn't one that's easy to find, and you'll be glad to know I have it all set up in my calculator ready to go. So I'm going to just grab this right here, and I'm going to use the calculator intersect feature in order to figure out where is that. Get my cursor close to the intersection. Press enter 1, 2, 3 times. And there it is. It gives me the answer. I'm just going to drag this over here for a moment. So I've got the number in front of me. Now that, which did I want, an x or a y value? I wanted the y value. Grab my highlighter just so we know. That's the y value I want right there. So let's continue writing our integral. Let's see, here we go. Y value, so 1.2517579. Okay, so I'm stacking my washers from 0 up to there. My big radius was here. We said it was negative 2y plus 6 squared. I'm going to subtract my small radius squared. That's going to be e to the y squared. That whole thing times dy. All right, these notes should help you do all of the problems where you're simply revolving around the x-axis or the y-axis using washer method.